Anybody have any WebAssign questions we need to go over? Got one?
It's the one, the latest part.
Okay.
One of the questions asked if the vertical line is the graph function,
Mm-hmm.
and then it asked for like the domaining range.
Domaining range. Okay. Yep. It's not as bad as it sounds on those. So. Yeah, I think you're right. Okay. Oh, maybe it's 4 of these. Like that one. Yeah. Okay. So yeah, this is something we need to talk about. I forgot to bring it up last time. You have 1 or 2 problems, not many, but you do have a couple in the graphs of functions assignment. Okay, so the first part it'll say, is this thing a function or not? So then you can just check it with a vertical line test. So on this one, no matter where we draw in a vertical line, it would only touch once. So this one would be a function. But the part that is maybe a little bit trickier, at least until you see how to do it, okay, is this part that says state the domaining range. Okay. So remember the domain's a set of, and it does say put it in interval notation. So remember the domain is the set of all x values, all the inputs that we can use for our function, and then the range is the set of all y values, or all the outputs that we get out of our function. So on this one, all you have to do is you just look at where the graph covers. Okay, so for x values, we go from -3 to +2. So our domain's -3 to +2 there, and as far as putting it in, we do have closed circles at both endpoints, so you include both the endpoints. So for putting it in interval notation, let's see here. We're including both the endpoints, so we would have brackets. So for that one, we would put in -3 to 2. Whoop, not that. -3 to 2. And that's the values that our function covers on the x-axis. So the first value we have is at -3, and then it goes all the way over to the right until we get to +2. Okay. Y values, same idea. You're just turning things sideways, thinking about it that way. So we want to know like what's the lowest point on our graph as far as the y-axis. So the lowest value would be -3 down here, and then the tallest portion of our graph would be here at 4. So our range on this one would go from -3 to 4, and again we'll have square brackets. So you have a square bracket with a -3 on the left and then 4 on the right. So it's not as bad as it seems like. You really, when you have the graph, the domaining range is not too bad. Let me check see if there was. Those didn't ask for that. That might be the only one that asked for domaining range on this assignment. Was there 2? Okay, maybe there's another one. Oop. Yeah, so here's another one. Okay. So this thing about domain and range on this one. The tick marks are a little bit confusing on this one because each tick mark is like 1/2. So if you go out 4 tick marks, you get to 2. So here for our domain, the x values we on the left side, we start at -1, and then we go to +1, and it includes both of those, so we have the square brackets with -1 to +1. And then for the range on the y-axis, the smallest our function gets is -2, and it goes to +2, so our range would be -2 to +2 on that one. Nothing too tricky there, but until you kind of see what's going on, it is confusing, for sure. Can be. Other WebAssign questions? Do you have something else? Nothing? Okay. All right then. We'll need to go to some graphs here in a minute, so I'll go ahead and load that while I'm here. And then we'll talk about our section for today. So today what we're going to do, we're going to look at if we start with the graph of a function and we add some number to it, or we subtract some number from it, or multiply by some number, things like that, what happens to the graph? And what happens to the graph? So we call doing things like that transformations, when we're moving our graph around or changing some graph that we start with. We say we're transforming the graph. So we're going to look at some of these things in this section. We're not going to cover everything you can possibly do to a graph, but we are going to look at a few different transformations we can do. The first thing we're going to look at is what we call a vertical shift. So a vertical shift, all we're talking about is moving our graph up the y-axis or down the y-axis. So moving it up or down. So writing out the rules, trying to explain what's happening on a graph is a little bit tricky to word so it makes sense. So here's how I'm going to write it down. I'm going to say we start with the graph of some function f of x. I'll start with. Right. So that could be any function. The main ones that we looked at last time, we have maybe x raised to some power, or we have like square root of x, something like that, or absolute value of x. So just start with one of those basic functions, and then if we add some number to our function, the way I'm going to write that down is f of x plus c. Okay. That's going to shift our graph vertically. And if we're thinking about c being a positive number, that's how much it's going to move our graph. So if we add some number to our function, then it goes up that many units. And if we subtract a number, or you can think about adding a negative number if you want to, it does just the opposite. It's going to be shifted down. So when we subtract the number, we go down by that many units. So vertical shifts work kind of the way you think they would. If you add a number, that's positive, so we go in the positive direction. If you subtract a number, that's negative, so we go in the negative direction. So up positive, down negative. So that's not too bad. So let me show you what I'm talking about, because that looks a little funny, saying like f of x plus some number there maybe. So look at some examples of how those could look. Okay. So here's a function that had a vertical shift applied to it. You could think about like x squared is like our starting function. Okay. Remember what the basic shape is with x squared? It's gonna look like, it would look parabola is what we call it, right? We would have like a U shape. Okay. And then the +3 out here, this part, that's going to shift our graph vertically. Which way? Up or down? Up, yeah. So it's going to make it move up 3 units. Okay. So whatever, we'll look at some of these, okay? But whatever our graph looked like to start with, and we're going up 3 units. Okay. Here's another one, maybe we're dealing with absolute value this time. Absolute value of x. We think about that as our starting function. What kind of shape is that graph going to have? Like a V, yep. And then -1 out here. Which way are we going to go for that? Go down 1 unit, yeah. Okay. And then maybe kind of one more way that could look, if we're dealing with a radical. Maybe we've got the like square root of x plus 2. Okay. So the +2 is outside of the radical. The square root of x, that's the one that starts at 0 and then kind of goes off to the right. Okay. So then we would have that graph, but it would be shifted down 2 units. Okay. So when you have your starting function, and then outside of that starting function, you have plus or minus some number. And it could be any number. When you have plus or minus some number, positive values means it's going up that much, negative values means it's going down that much. Yep. Oh, no, it should be up. I'm sorry. Yeah, thank you. Thanks for pointing that out. That would have. It should be up, yeah. Okay. Thought one thing, wrote the opposite. So. Yeah, so up's positive, down's negative almost. So that's up and down. Okay. The next kind of transformation we need to talk about are horizontal shifts. So that's moving our graph left to right. Okay. So again, we're going to start with some basic function. Okay. And this time, let's see which one I want to do first. Okay. So this time it's going to look a little bit different, and it'll make more sense when we see the examples, but the plus or minus that we're going to do on these is like inside our basic function with the x. And so on the vertical shifts, the plus or minus is kind of outside. Here, these horizontal shifts are going to be inside with the x. So if we have f of x minus c, okay, these are almost kind of backward. If you stop and think about it, it makes sense, but just initially, on first impressions, they seem kind of backward. If we subtract some number from the x, that means we're going to move the graph to the right c units. So with horizontal shifts, subtracting means we go to the right. And then if we add a number, we'll go to the left. Okay, so adding positive values means we go to the left. So have to remember the horizontal ones are kind of the reverse of what you might expect to start with. And the way these look when we apply them to some function, so like if we have x raised to the power as our starting function, then maybe we would have like x minus 3 squared. And so the minus 3 is inside the squared part, and it's in there with the x. So since we have minus 3, which way is that going to make our graph go? To the right, yeah. So this will make our graph go to the right 3 units. Yeah, it is opposite, yeah. Yep. If we have something like absolute value, then it would look like, then it would be inside the absolute value with the x. It would be a horizontal shift. But this one, since it's positive 1, we would go to the left 1 unit. So what I'm saying is, like, if we start with absolute value, then when we add 1, we're going to the left 1 unit. I kind of made that look diagonal. And then if we have a radical involved, the way they look, is we'll have plus or minus some number underneath the radical. That would be a horizontal shift in this case. So minus 7, it means we would shift the graph to the right 7 units. Questions on those? Okay. So another type of transformation you might think about, right? We've got up and down, we've got left and right. Maybe you might think we have to do something fancy if we want to do like a diagonal move. But that's not really the case, because if you want diagonal movement, all you're doing is you're putting together horizontal and vertical movement. Right? So instead of thinking about going diagonal, we can think about going like to the right a certain number of units and then up a certain number of units. Right? That would give us a diagonal result there. So just putting together horizontal and vertical. Okay. So let's think about one that has both done. Okay. On this one, we have a vertical and a horizontal shift. I usually like to start with the vertical shift just because they're easy to pick out because they're outside of everything else. So here we've done +5, so that means we would start with the graph of x squared, and it's like our basic function, and we would move the graph up 5 units. And then we've got a horizontal shift in here. So since it's -1, which way would we go? We would go to the right 1 unit, yeah. So I don't have a grid over here, but if we started with our parabola, and that says we should go up 5 units, 1, 2, 3, 4, 5, and then to the right 1 unit. So then our new graph would look, it would be over here. Be kind of a diagonal shift there. Okay. Questions on those, vertical or horizontal shifts? Main things to remember, okay, you need to remember which one's which. And then you kind of have to remember with the horizontal ones, you kind of have to think about it backward, or at least I do, the way my brain works. Okay. So the next kind of transformation we need to talk about are reflections. So with reflections, it's just like what it sounds like. It's like looking in a mirror, right? You're flipping the image around. And we have two ways we're going to think about reflecting our graph. Either we're going to reflect it over the y-axis, so it'll go from like this to like this, or from like this to like this. Or we can do x-axis reflections where like the left side and the right side switch. We're flipping across the y-axis there. So the way we end up with these things, and we're going to start with some function. Okay. And the way we get these two types of reflections are we have a minus sign somewhere. We're changing the sign. So if we just throw a minus sign out in front of the whole thing, that's a reflection over the x-axis. So the minus sign here gives us an x-axis reflection. And another way of saying that, instead of saying it's reflected over the x-axis, we could say we're like switching the top and bottom of our graph. And so stuff that was up in the positive part goes to the negative part, stuff in the negative part goes to the positive part. Okay. And if you try to think your way through that, that's really not all that bad, because like if we were getting a positive value for f of x, then when we put the minus sign out, that means we have a negative value. So it changes what we were getting as a positive y to a negative y. So it flips top and bottom. If we were getting a negative and we throw another negative out in front of it, changes it to positive. So it flips top and bottom. Okay. And then the second one, is when we put the minus sign inside of our function with the x. We get a y-axis reflection. So minus sign inside, we get y-axis reflection. So what's happening there is we're changing the sign of our x values. So that's flipping the left and the right side of our graph. And so that's like switching the left and the right. Mm-hmm. And top and bottom if the minus sign's out. Yeah. So the way these can look when we're writing down the function. So here. So maybe we'll have like negative x cubed. So the minus sign is just out in front of the whole thing on that one. So this would be an x-axis reflection. Top and bottom would be switched. If we wanted to do a y-axis reflection with one like that, it would look like this. We'd have parentheses and then negative x, and then that would be raised to the third power. And then minus signs on the inside. That would be a, no, sorry. Yeah, no, that's right, that's right. That would be a y-axis reflection. Y-axis reflection. Okay. So with this function, if you remember the basic shape, well, it's going to look like this. So if we do an x-axis reflection, that would mean it switches and looks like this. No, x-axis reflection means it flips over. Yeah, it does. So x-axis reflection means top flips down to the bottom, bottom flips up to the top. Okay. You'll see why this one's a little bit confusing. Because we start with our basic function on this one and do a y-axis reflection, switch the left and the right, it still looks like that because the right side's gone to the left side's gone to the right. So with x cubed, if you're just looking at the graph and you don't have the function, you can't tell which one's been done. Because if you flip top and the bottom, or if you flip the left and the right, they look the same. Because that one has some symmetry. Okay. It's easier to think about what happens with one like this. So let's do negative square root of x. We've got the minus sign out front. That's an x-axis reflection. Going to flip the top and the bottom So our function starts off looking like this. And if we do an x-axis reflection, it would look like this. Well, if I can draw it better. This. And it flips the top and the bottom. Like here's our axes there. If we move the minus sign to the inside, so we would have square root of negative x. And since the minus sign's on the inside on this one, that's a y-axis reflection. Okay. So thinking about our graph, let me actually draw some axes here. So start with this one, square root of x. Then if we do a y-axis reflection, the left and the right get switched, so this one goes to the left instead of to the right. And then if we can do the same thing with absolute value. It's really similar to the absolute value. I mean, we can do radical square root. No, that's the value. I don't know where my brain's at today. I'm sorry, y'all. There's the two with absolute value. So, which one switch here? On the top one, the minus sign is inside with the x. So that's a y-axis reflection. And on the bottom one, the minus sign's out in front, so that's an x-axis reflection. Any questions on those? Or did I get anybody messed up? Okay. One more type of transformation. Okay, so we've got the shifts, reflections, and then one more. The last one we want to talk about is if we either stretch or our textbook calls it shrink. Maybe a better thing to say is we would compress the graph. Or even a little more informally, I kind of like to call it squish. So to do one of those transformations, we get our starting function. And then we're going to multiply it by some number. So when a stretch happens, is when the number when multiplied by our function is bigger than 1. Oh, I said C. A. Stretch. So if we multiply our function by some number that's bigger than 1, then it's going to stretch our graph. Okay? And if you think about multiplying by a number bigger than 1, so let's say we're going to multiply by 2, and if you multiply even just a number by 2, it makes the number bigger. So if we multiply a function by 2, it's going to make the graph bigger, and the way that shows up is it's stretched out. Okay, it's stretched out. The way we get shrinking or compressing that's supposed to say if up there too, is if the number we multiply by is somewhere between 0 and 1. So like a fraction, right, that's smaller than 1. Like if we multiply our function by 1/2, okay, then that's going to make it smaller. Right? If you take half of something, it's going to make it smaller. So if we take 1/2 of our graph, it's going to make it smaller. It's going to be compressed or shrunk. I'm going to think about it that way. Okay? Not always written as a fraction. You could have like 0.33 times the function. That's between 0 and 1, so that would shrink our graph. Okay? So it would shrink if between 0 and 1. Negatives we don't include, because when we're thinking about transformations, and if we put a minus sign in there, we're actually doing a reflection because of the minus sign. So if you multiply by a negative number, you're really doing two transformations. You're doing a reflection, and you're either stretching or shrinking the graph. So we only have to worry about the ones that are between 0 and 1 and then bigger than 1. If we put a minus sign in there, we handle that separately with the reflections. All right, so let's look at some graphs. Got a graph set up for us here. So that's it. I've got some little sliders set up so we can change the numbers easy on these. So here I've got my basic function would be x squared, and then I've got plus some number. So if that's positive, that would be adding a number. If it's negative, that's like subtracting a number for our horizontal shift. And then plus some number out here. So positive would be up, negative would be down, and then we'll multiply it by some number. So bigger than 1, stretch, smaller than 1, compressing. So this is what we're starting with. Right now I've got it set to where we don't have any horizontal shift or any vertical shift, and it's just multiplying by 1, so that doesn't change anything. So 1 times anything is itself. Okay. So let's change some stuff around. So like we're gonna do a positive number on the outside, that'd be doing a positive v or negative v. Okay, but if we go positive, it's going to move our graph up from where it started. If we go negative, it'd move our graph down. And maybe we could zoom out a little bit here. Okay, so that's horizontal, sorry. Let me get back on 0. The vertical, we just add some number or subtract some number from the whole thing. We'll move it around. Okay. Horizontal, if we go to a positive number, we add a number that moves our graph to the left. If we go to a negative number, it moves our graph to the right. Okay. And then the last one, where we stretch or shrink, maybe this will give you a better picture of what goes on here. If we multiply by something bigger than 1, it stretches our graph. So I like thinking about this kind of like pulling on a rubber band. You know how it gets skinnier? If we go to some number smaller than 1, let's see if I can get here, it starts making our graph wider. And then we can do the same thing with our others. So here, we'll put all 3 of them on there. Okay? So pink one's absolute value. Blue one's square root of x. Okay? So we can do a vertical shift. It just moves everything up or down. We can do a horizontal shift. That just moves everything to the left or to the right. And then with the stretching, let me move it down a little bit. So if we stretch these things, square root of x is the weirdest one, the blue one, because when we stretch it, it almost doesn't look stretched. It almost looks like we zoomed in on it instead of stretching it. And then if we shrink everything, let's see, it kind of flattens everything out. And then of course we can do, we can do multiple things, right? We can move it and reflect it also. So let me look at the reflections here. Okay. So if we want to do a reflection, let's just look at square root, because it's one where we can see both kinds of reflections. With the parabola and with the absolute value v, when we switch left and right, you can't see it because it looks the same. With square root, we can see it. So if we put a minus sign out in front of the whole thing, I'm going to flip top and bottom. Okay. Or if we put the minus sign inside with the x, it flips left and right, so it goes over to the left instead of to the right. And we could do both, right? We could do both. So if we do both, and we get that picture. Now it's been flipped to the left, and then it's been flipped down. Questions on any of those? No. So let's just look at a couple more examples here. So something else we need to be able to do is we need to be able to go the other direction as well. So we need to be able to say, okay, write down the equation if it's been shifted up by 2, left by 1, and stretched by a factor of 2. Okay, so how to do that. So let's look at one like that. So we'll use square root of x. Okay. So we want to find the graph that's been shifted left by 5 units and reflected over the x-axis. Okay. So we we want to go left 5 units. That's horizontal. So we kind of have to think about that one backward. The left 5 units means we're gonna do a +5. And where's the +5 gonna go? Is it gonna go on the outside or is it gonna go underneath the radical? It's gonna go underneath it, that's right. So we'll have square root of x plus 5. Okay. And then if we want to reflect over the x-axis, I switch in the top and the bottom. So we need a minus sign. So should our minus sign go out in front of the radical or should it go in front of the x? This one. This is a little hard to remember. We want to flip top and the bottom. We really want to switch the signs of all of our outputs, so we could put the minus sign out in front of the whole thing. That would be our function there. So our reflection, so this is x-axis reflection. And then this -5 that's inside would be left 5. I want to be able to go both ways on that. Now let's do one more where we got several things going on. So I'm going to give you a function and we just want to know what transformations have been done. So here's our function. We've got 2 times x minus 3 squared plus 1. So what all's been done to this one? We really have 3 things. So we can name them in any order. Okay. What do you see? The easiest one for me to pick off, if I'm just trying to look for an easy place to start, is out here. I've got a +1 on the whole thing. So how's that going to move the graph? Up 1, yeah, it's vertical, so up 1. Okay. And we've got 2 other ones. Not on this one. That is a possibility, right? But on this one, this is positive and that's positive, so we haven't had any reflections done. We are multiplying by 2 though. So what's that one going to do to it? 2 is bigger than 1, so that is a stretch. Yeah, it's a stretch. So this one is stretched by 2. Or stretched by a factor of 2. And then what's our other piece we've got in there? We've got the, got the -3 inside. That's going to be to the right 3. Yeah, to the right 3. Okay. And that one's, we just started with a parabola. Moved it up 1, to the right 3, and then it got stretched by a factor of 2. Okay. Questions on those? Nobody? Okay. So that's the end of this section. I got one other thing for us to do today. Let me